today's class we're going to be doing about carbon and its compounds. So before we even start the class, I just wanted to know which are the most common things that come to your mind when you think of carbon. So assuming I'm getting the answer as pencil from a lot of students, because that is what the first answer they would usually give, and before that even they would give the answer as charcoal, the coal that you see around. So those are the two common answers that students usually give for carbon. So with that background, we'll start the class about carbon and its compounds. So these are some of the most commonly occurring carbon compounds that you find around you. The first one obviously is the charcoal that you see here, and the second one is something that you use always, every day in your class, which is your pencil. Now there has always been a confusion as to, people say that pencil is made of lead, but that's something wrong that you have to learn right now. Pencil is not made of lead, but it's made of a carbon compound which is called as graphite, right? And finally, a woman's best friend, as it's usually called, and chemically it's the hardest naturally occurring substance on earth, which is the diamond. So these are different forms of carbon that you see all around you, and these forms, how are they made? What are the bonds that are involved in formation of these naturally occurring compounds? All that we'll see in the upcoming slides, right? So, it always occurs as a kind of a wonder for me that this coal or the charcoal is so black in color, the graphite is also so black in color, but diamond alone is like white, right? So what do you think makes diamond white? Coal, when you think of carbon itself, it's something black substance, something, solid like this. Even in a pencil, when you see the graphite, it's black. But how did this diamond turn out to be white in color? So, any guesses for that?
It is due to the pressure and the heat inside the earth. It turns
Okay, so usually the answer here would vary, saying that in diamond it is polished and it is cut from charcoal. The polished form of charcoal is diamond, and it's not a wonder that some diamonds are found in charcoal mines, which is correct answer. Assuming that we've been given this answer, we'll continue. Okay, so we saw that the carbon is a very versatile element which occurs in the Earth's crust and in the atmosphere, obviously carbon dioxide. But the most fascinating thing about carbon is that there is only 0.02% of carbon in the form of minerals like carbonate, hydrogen carbonates, coal and petroleum. And even more fascinating fact is that the atmosphere that we breathe has just about 0.03% carbon dioxide. But in spite of all these meager or all these small digits that you see regarding the occurrence of carbon, it is one of the most widely occurring elements in nature. And how does it do is, carbon is able to combine with atoms of other elements and thereby make it existent. But as carbon, it exists only in a very, very less or a very, very meager amount, right? Okay, so about the history of carbon, we know that carbon occurs in in the earth crust in the form of minerals, but has there been some kind of a historical reference to carbon? Where was it first found? What kind of uses were carbon put into in the previous days or in ancient civilizations? So the answer to that is yes. Carbon history dates back to about the Egyptian civilization. So around 1300 or probably more than that years back, when and it was first cited on an Egyptian papyrus about the occurrence of carbon. Not only that, Hippocrates, who was supposed to be the most important person in medicine, he has used charcoal for the treatment of certain intestinal ailments. I mean, we really don't know how that actually happened. We can probably just read up a little bit more on that, because it sounded interesting to me that somebody used charcoal to cure an intestinal ailment. So that was definitely a wonder that came across me. So maybe we can just read up a little bit on that, probably towards the end of the class, and we have a discussion on how charcoal could have been used as an intestinal treatment method or equipment, right? Okay, so here you see some of the compounds in which carbon is present, though it is bonded to other atoms of other elements. So here you see sugar molecule, which has got carbon and oxygen. Along with it, it's got hydrogen also, which are the smaller dots. Ethanol is again another alcohol, naturally occurring alcohol that is present. Here again you have carbon, hydrogen and oxygen. And amino acids. Amino acids are building blocks of protein. They also contain the backbone of an amino acid is carbon, hydrogen, oxygen, along with traces of nitrogen. Right? So these are some of the examples where you find carbon, or I could put it this way, these are some of the compounds in which carbon is there. And these compounds are present everywhere. You see sugar everywhere, you see an alcohol, you see amino acids, which are building blocks of protein. Also you have fats, right, which are the which store energy for us. So all of them have carbon incorporated into their backbone, and thereby it is a very versatile element and it's widely seen. And such compounds which have at least one carbon atom is called as an organic compound. And so we are dealing with everything that is organic in the next few slides. Okay, so carbon and its bonds. Now the atomic number of carbon is probably a very small element. Its atomic number is just 6. So anybody has an idea about how the electronic arrangement is done? Yeah, so any atom has got the center or the core, which is called as the nucleus, and in the nucleus you have the presence of charged particles, positively charged particles, protons, and neutrally charged particles called as neutrons. And spinning around the core or spinning around the nucleus are clouds of electrons. So depending upon how many electrons are there, a particular element will have an atomic number. Right? Now for carbon, the atomic number is 6, which means that it's got 6 electrons which are revolving around a nucleus. The nucleus has got 6 protons and 6 neutrons. Right? Now, can anybody guess why the number of the protons, electrons and neutrons are the same? Okay, so in such a case, students generally say that the charges have to cancel out each other, only then it will be a stable atom. So assuming we get an answer like that, we will continue. So yeah, so to cancel out the charges and make it a non-reactive atom, you have the charges balanced by the positively charged protons which are present inside the nucleus and the negatively charged electrons which circle around or which orbit around the nucleus of the atom. Now, these electrons are arranged in different levels, also called as the electronic shell. So if you see here, carbon has got 2 shells, one inner shell and another which is outer. Right? So it's a relatively small atom, got just 2 shells. And how the electrons are arranged? So usually the electrons are arranged, the first shell always has 2 electrons. The second shell can hold up to 6 electrons. Okay? Now, the atomic number is 6, therefore, the first shell will hold 2 electrons. So 6 minus 2 is 4. The second shell will hold only 4 electrons. Right? And since this is the outermost shell of carbon, this shell is also called as the valence shell. That means there are no other shells or no other electrons beyond this outermost shell or the energy level. That is why it is called as a valence shell or the outermost shell. Generally, in any atom, the electrons in the outermost shell are reactive. That is, they participate in bond formation. Right? That is why you get various compounds that are present. For example, carbon will combine with oxygen to form carbon dioxide or carbon monoxide. So for that, there has to be a sharing between the carbon and the oxygen in terms of the electron. So the electron that is shared between two atoms of different elements or the same element will form your compound. Okay. So now we know that carbon has got four outer electrons, right? So therefore it's got a name called as tetravalent. So tetra means 4 and valence, because it's in the outermost shell, we saw that the shell is called a valence shell. So it is supposed to be a tetravalent atom, right? Okay, so again depicting it, it has 4 electrons in the outermost shell, so therefore its valency is 4. So valency is the property of the atom to give its electrons, right? So different atoms have different valencies because of depending on the number of electrons that are present in the valence shell or the outermost shell. So here we have carbon, which has got 4 electrons in its outermost shell, or in other words, it's got a valency of 4, or a simpler term, it is tetravalent. Okay. So every atom will either accept electrons or donate electrons to reach a stable configuration, right? Or a noble gas configuration. So the noble gas configuration, which is the which is in the vicinity of carbon, is neon. Neon has an atomic number of 8, right? So for carbon to achieve the atomic number of 8, it has to either accept 4 electrons so that it becomes 8 outside, right? Or it has to lose 4 electrons so that it becomes helium, which is the other noble gas in the vicinity of carbon. Okay, so there are 2 scenarios. Either it accepts 4 electrons and gets the stable configuration of neon, which is 10, or it has to lose 4 electrons and get the stable configuration of helium, which is 2. Right? But carbon has a dilemma right now. It's in a fix. It doesn't know what to do. Should it give away its electrons and become helium, or should it accept electrons and become neon? So we'll see what carbon does. Okay, so it does not gain 4 electrons. Why? Because if it gains 4 electrons, then the total will be 10 electrons, right? But how many protons are there in the nucleus? Right, there are only 6 protons in the nucleus, which will not be able to hold the 10 electrons in place because the negative charge will overcome the positive charge, right? The other scenario is wherein it has to lose 4 electrons. Okay. Now, it's very difficult to lose even 1 electron because it involves a lot of energy to remove the electron. So just imagine for 4, it's going to require huge amounts of energy, enormous amounts of energy, right? So it is something like when you can screw in something, but then pulling out the screw, it takes so much of the time. It's just like that, right? You need enormous amounts of energy to remove something. So even fixing here, the problem here is there is no balance in charge, right? So carbon does not do either of the situations. It neither gives away the 4 electrons, nor does it gain 4 electrons. So it came up with a strategy to bind with other atoms of other elements, saying, let's just share the electrons with each other. Okay. So here there is a small scenario as to how the bond between carbon and other atom happens. Okay. So let's just say Emily is carbon and say Sarah is another atom. Emily and Sarah, both of them are feeling cold. Yeah. So what they do, they have only one blanket with them. So what do? They share the blanket amongst themselves so that both of them are comfortable. Right? So it's neither Emily is taking the blanket nor Sarah is taking the blanket for herself. But they both are sharing the blanket so that both of them can be comfortable and cozy. Right? That's exactly what carbon also does. And this type of bonding where the electrons are shared between the atoms is called as covalent bonding. Right? So carbon shares its valence electron with other atoms or atoms of other elements, and this is called as the covalent bonding.